Okay, so now we can proceed. Okay, so what we are looking at is we are going to be looking at this particular question. So limit, find the limit for this function when what? When x goes to 4. So now we know from what we did last week to say you can't plug in 4 because the moment you plug in 4, this whole thing becomes undefined. Rather, the approach that you want to take is you want to find the common denominator for the numerator. Okay, so what you're going to do is to that. So when you do that, you're going to get a 2 and you're going to get a square root of x, isn't it? That's going to be all over x minus 4, which was our initial numerator. So then, like we did last week, then once you reach at this point, you then want to uh, get rid of the denominator of the numerator. So in short, you want to get rid of this. Okay? So what do? You multiply through by what? You multiply through by that. So you cancel that. So then what are you going to do then at this point? So then uh, what you are then going to do at this point is, so you cancel that, then you are going to have, okay, okay, yeah. So you you've made that the subject of the formula, and then if you multiply through by that, you're going to get that. So then what then we are going to do, we want to then multiply the through the numerator, right? So I want to multiply through the numerator and that. Or if you want, you could actually use another method. So the other method that you would use, rather than finding the common denominator from here, you can actually go by another route. Of course, it's always good to be able to use different routes. So yeah, so this is one method that we are using last time. Okay, so then what then are we going to do? So when we want to when we want to do this, then we can now proceed and say we cancel that, we are going to have 2 and that, isn't it? So that has cancelled, and then you are now going to have 2 by x minus 4, isn't it? Then again, once you reach at this point, you you are still having a surd, isn't it? Or you're still having a radical. So what you want to do is you see, okay, how can I simplify this? Because really there is nothing much that you can do at this point. And worse off is that if you try to plug in 4 in the denominator, you are still getting a what? You are still going to get a 0, which is something that we've been trying to avoid since we started. So it would really defeat the purpose if we thought by now we are done. So then what you are then going to do at this particular point is then to say, how can I use the knowledge on sides to be able to manipulate this particular question further? So that's now what we are going to do. Okay, so that's now what we are going to be looking at. So now, using our knowledge of sides, what we are going to do is we are now going to use the conjugate of the word. We are going to use the conjugate of the numerator. Okay, so we are going to use the conjugate of the numerator. So we are going to do that. So we are going to get that. So we are going to get that. Then that's it, right? So then multiplying through, of course, we did how to multiply these. So you do this, 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 that, right? So our value is going to be so then for the denominator, what we would do is you can see that it anyway, but we'll just leave it like this. And the reason why I want to leave it like this without uh, having to multiply it through, it's because you see when we, because remember, once you do a conjugate, once you multiply the conjugate, what you are getting is a difference of two squares. So what this basically means that you see these mid terms, the middle terms, they are cancelling, right? And then what you will realize, like we were realizing in last week's questions, is that you see that, okay, so remember that on all these parts, always remember to put limits. Huh? So here, there should be limit x to 4. Then even here, remember to put limit when x goes to 4. So ensure that everywhere there are limits. Huh? Limit when x goes to 4. Okay, yeah. So always include those as you are solving. So limit as x goes to 4. So now, you now realize that the term which is on top is what? 4 minus x, and then down you've got what? You've got that. Now you will realize that what is on top, 4 minus x, is basically what is down, but just multiply it through by what? By a negative 1, isn't it? So then what you're going to do, because remember our problem is what? Is the x minus 4, because it's what's causing us not to be able to what? Not to be able to substitute in or to plug in our what? To plug in our 4. So what we are going to do is we'll say we've realized that, okay, so we're going to say limit when x goes to 4. So we say minus 1, that's x what? X minus 4. So you see over to that, then that, and then you are going to have that. So now this is what we wanted, because now we can cancel that, we can cancel that. Don't forget the negative 1. Don't forget the negative 1. Then what are we going to have? That. Then, okay. Then from here now, it's all about now we can plug in our 4. Why can we plug in the 4? Because we know that we've gotten rid of the x minus 4 so you won't get an undefined answer. So 2, you substitute 4 there. So okay, here let's still put limit. We only remove the limit when we've when we've substituted the 4. So in this one we've substituted the 4, so that's why we are not putting the limits there. Okay, so then we are going to have -1 over, okay, so there we are going to have that's going to be 2. Okay, so that's going to be 2 times 2 the square root of 4. Then there we are going to have 2 plus 2 because of the square root of 4 again, right? So what we are going to have is -1 over 4 by 4. So what we are going to have is negative what? -16. Yeah, so that's basically how you go about that. So now that's basically how we would go about that. So now, how then can you determine the limits using a graph? So we're going to look at a particular graph, and then this is just going to be able to be helpful to help you be able to figure out what the limits are, getting them from a graph. Then we can look at continuity. So we have that, then we have that, so we have that. Okay, let me draw properly. So we have that, and then okay, let's do this. So that's the x-axis, the y-axis, 0, then that's we've got 1, 2, 3. So that's -1, -2, -3. That's -1, -2, -3. 1, 2, 3, 4. Then we have 1, 2, and 3. Okay, so now we have graphs. So from 3 we've got that going to the left. Then from the same 3, but at point -3, we have this. So you see that this is shaded, right? Yeah, then when it goes at 2, it's not shaded. So I hope people can see the difference. Then it moves up. So it moves up, passes through 1, and then stops at 1, and it's not shaded. Huh? Okay, so you see it comes like that, and it's not shaded. Okay, so I know this is quite lengthy, but I feel they are very, very important concepts which are going to help you, especially when we talk about continuity. So when we talk about continuity. So we are going to have that. Then from here, we are going to have that. Then 3 there we've got the vertical asymptote. Then you are going to have that. Okay, great. I know this was quite lengthy, but I feel the concepts which we'll get from this, I feel they will be very, very helpful. Okay, so now let's now start. Okay, so okay, so then what are we looking at? So let's now say we are looking for the limit. So remember, we are saying limit when x goes to -3. Now remember, -3 is here, right? -3 is here. Now there are two ways in which we can go towards -3, from the left or from the right. So when we are coming from the left, going towards -3, we put a negative on the number. So you've seen that negative number that I've put, right? So then what then you are looking at is this. So coming from the, so now let's look at -3 and say on my curve or on my graph, when I look at which part of the graph has got x approaching -3 from the left, you see that it's this one, right? The one that I'll draw in black. It's when we follow this graph, right? And you see that at which level is it at? So it's supposed to be at 1, huh? It's just a mistake in drawing. Yeah, but it's supposed to be at 1. So you see, that means that the limit at that point, when x goes to -3 from the left, it's going to be what? It's going to be 1. Why? Because when you follow coming from the left, the graph of this particular function is at what? Is at when you follow it through up to the y-axis, it's what? It's at 1. Now, then if you now say, let me now get the limit when x goes to -3 from the right. So you see that's the positive that I've put there. So then what are you going to look at here? So you can't look at the graph that the part that we looked at in black, no, because that's from the left. So what you are going to do is you want to look at, you've seen this same blue line that I drew, I'm now drawing in black. So you want now to look at coming from the right. What graph is there coming from the right? It's this one. You've seen this graph. So coming from the right, you see that at that point 3, okay? At that point 3, what is the value of this function? You see it's what? It's -3. So meaning the limit is what? Is -3. And when we talk about continuity, you'll then be able to appreciate to say, just from this, you can tell that this function is not continuous. Why? Because the limit coming from the left and the right on the same x value, if this graph is continuous, then these values have to be the same. And of course, you can tell that our graph is even telling us that that this function is discontinuous at -3. So we'll look at questions on continuity, but I just wanted this graph to be able to give us that perspective. I think it would be very helpful going forward. So now, so now, if then you are asked to say, find the limit at -3. So now see the difference. This limit, I've just written it without putting either a plus or a minus. Of course, f of x. So you see, I've not put any plus or minus on top of the -3. So this means now I'm now talking about the total what? I'm now talking about the total limit or the entire limit. Now, if coming from the left and coming from the right, the values I'm getting are different, then what does this tell me? This tell me that the limit does not exist. It does not exist. So does not exist, right? So it does not, so the limit does not what? Does not exist. does not exist, right? So this is very, very important, and you see the importance as well when we talk about what when we talk about continuity. So these limits, the ones that we found here and here, they're what we call one-sided what limits. So one-sided limits in the sense that coming on either the left or the right to that particular point, yes, you can find it. But you remember for the limit to be there, these two values have to be the same, right? So let's look at another example. So we now go to D. So then now when you're asked to say what is the value of the function at negative 3. So at negative 3, what is the value of the function? So you just go to the graph and say, now you follow what? You want to follow the path or the graph, the part of the graph which is what? Which is shaded. You see, this one is shaded here, right? At negative 3 is shaded. So it simply means you just follow it through and it takes you where? To the value of what? To the value of the function, which is negative 3. So what I'm saying is, here we are saying the value of the function when x is negative 3. So you go where negative 3 is and you follow the one which is shaded, because the one which is shaded is simply saying 3, yes, is part of the function. Unlike the one on top there where it's not shaded, it simply means that the what's this is not included. That negative 3 is not included on top, but is included where? At the bottom, right? Of course, there. And when we take it to the y-axis, we see that the value is actually negative 3. Okay? So that's an important point. Then E, limit. So then we want to say limit on negative 2 coming from the left, because of that minus sign I've put on top for the function. So you go on minus 2. Where is minus 2? So minus 2, of course, having drawn it properly, minus 2, this unshaded part has to be at minus 2. Huh? So looking at minus 2, what are we getting? So what you coming from the left, what you're doing from the left is you're asking yourself and saying, what value am I getting as I'm approaching negative 2 from the left? You see that it's going to be what? It's going to be negative 2. You're on the y-axis, isn't it? So you're getting negative 2. Then you now say the limit. So you're now going to say the limit when x is going to negative 2 coming from the right side now. So that's like a plus there that we're having on top. So again, you will realize that coming from where? Coming from on top, you see that, or rather coming from the right towards negative 2, you see that you are still finding what? Negative 2 there. So this means that the limit is what? Is negative 2. So now you see that the limits that we've gotten coming from the left and coming from the right is the same. So it means that so then you look at infinity at s goes to negative 2. You see that that one has got no positive or minus sign. So now we are now asking ourselves, is there a limit at this point? So we see the answers that we found are the same. So yes, there is a limit. So that's about it. Now how do we find the f Okay, so we're going to put this as f. Okay, so f. So then how do we find the value of the function at -2? So if you go on the graph and check where on the graph am I having -2 having a shaded dot. You see it's this one, isn't it? And what's the value? It's what? It's +2. So then, so your value is going to be what? It's going to be +2. Right. So really, so that's really the key thing. Let's look at other examples before we can talk about continuity. So okay, so let's just use this part. So let's start from here, G. So okay, so now again the same thing. We are approaching +1 from the left. So practically what we are looking at is this. So what we are having is, okay, just rub that. Let's just rub that. Okay, so then what we are having is, so is that one. So coming from the left, going on one, on +1, coming from the left. Okay, I've deleted something there. Okay, but the graph was going like that, right? So you will realize that coming from the left, going towards 1, what are we seeing? We see that we are going what? We are going towards a value of 1, okay? Because there is 1 at this point. So we are going to have what? We are going to have 1. Okay, so that's our limit. So our limit of this function from the left going towards 1 is what? Is 1. Then the limit of this function when x approaches 1 from the right side is going to be what? So again, you're asking yourself, now coming towards coming from the right, you are now going to come from here, and you see what's the value there? Where I've put a tick, you see that? That's where from the right, that's where you're going to come to your 1 point, isn't it? So you are seeing that that's going to be 3. So then the question you're asking yourself is, does a limit exist for this point when when x goes to 1, and it does not exist? Why? Because these don't are not the same, rather. Okay, then we now go to h, where we say f of 1, the value of 1. So where do you find the value of 1 on this graph? So you see that both on top, I don't know why I keep rubbing these graphs. So yeah, so that was the value. So you see that there on 1, find the value of this function. You see, there's a dotted line here at 1, that's at 2, right? So meaning the value of the function at 1 is what? Is 2. Then now the last thing that we'll look at is the infinities now. Okay, we're now looking at the infinities. So limit when x approaches +3 from the left side and the limit when x approaches from the right side. Then x of x. Then we're now trying to find the value of the function. So, so what then you are looking at for this function is where is positive 3? So, so so you see, coming, let's use blue. So you see, coming from the left, you are not really reaching 3, but you are going to negative infinity, isn't it? And then coming from the right, you are going where? Positive infinity. You've seen that, right? So you see that coming from the left, you are going continuously downwards without reaching any number. So you are going negative infinity. Coming from the right, you are getting what? Positive infinity. So this is what we are getting. So then we are going to have negative infinity. Then we are going to have positive infinity. So then what do we know about the limit? Does not exist. Okay. Then what's the function value? There's a vet consistent there, and we know say what undefined. So that's really the thing about it. So there's someone that asked about limits at infinity. So before we can look at continuity, we want to look at this. So the key thing when we're looking at limits with infinity, you are basically looking at, usually it's all just going to come down to, is it going to be positive infinity, is it going to be negative infinity, or is it going to go towards a what? Towards zero. Usually that's what you are looking. Of course, there may be certain cases where you may get numbers, normal smaller numbers, but it's relatively, yeah, it could happen, but it's relatively rare. But otherwise, it happens. So just take note of that. So limit of the function x squared when x goes to what? To positive infinity. So then, what then does this tell us? So then, what does this tell us? So what this tells us is, if x approaches infinity, as x approaches infinity, and we are squaring that, it simply means it's going to be infinity, positive infinity, right? Positive infinity. Positive what? Positive infinity. And even if we were to say the limit when x goes to negative infinity is x squared, again it's going to be what? It's going to be positive infinity, isn't it? So that's an important point to take note of. And then you also want to take note of this. And why am I putting this? It's because these are the common things that you'll be able to find. So, okay, so we've got that. So, what's going to be your value? So here, this is positive, huh? Positive infinity. So positive infinity. Okay, that's power 3. We get positive infinity. Then to negative infinity, we are going to get negative infinity. Because what this basically means is if you've got a very big number, you multiply it times -1 times -1, you're still going to get a negative big number, right? So that's that's very very important as far as the fundamentals are present. So then let's now look at more detailed examples. Okay, so going to negative infinity. So how do you go about this question? So there is something that you'd want to know about the significant values, okay, or the significant things. So what are the significant things in our calculation? So when you look at this function which we've been given of 5, that won't really have an impact, because for instance try to think of this. If x, because remember we're saying x going to negative infinity, so if we say x is negative 1000, 5 will remain the same, and if we plug it here it's going to be what? Negative 2000, isn't it? But when we plug it here, oh my goodness, it's going to be what? That's negative billion. But because of the negative outside, it becomes a what? Positive billion. So why am I writing this is so that you can understand why it would be easier to even think of, the other terms, the two terms which we have, these two, we can call them relatively insignificant because even though they are present, but they won't affect our answer by a large margin. And so what we prefer to do is to focus on what's really going to affect our answer by a large margin. So what then we are going to do is we are going to say, okay, let's just focus on what's going to affect our answer by a large margin. Because for instance, the example that I gave us, we are going to have 5, then you're going to have plus negative 1000, then positive 1 billion. So what difference does this really put on 1 billion? Very, very small difference, right? So that's our understanding. So we are going to get this and say okay, so we get the negative 1 out. Then we say if we are to put a very big number inside and we cube it, right? Okay, we cube it, we are going to get that negative number. So whatever number we're going to have, it's going to be big, but it's going to be negative. But remember, the outside has got a negative already, so positive infinity. Like that example that I had shown us with the 1 billion. So really, that's really the key thing when it comes to these things, right? So very very important to take note of these things. Then really, so you see that when you've got uh, when you've got something quite standard as without any denominators, it's pretty quite straightforward. Okay, so let's just look at another easy example so that we can, before we can go to those which will require us to go a deep further. So again, here is the key thing. We look at for which one is going to have the most impact. Of course, we know cube is quite big, but of course, in comparison to the power 4, that's going to have what? A bigger impact. Okay, so you do that, then you're going to say negative 5x to power 4. Then you're going to have negative 5, then that, then that. Then remember, you multiply a negative number power an even index. What do you get? You get a positive number, isn't it? So, and then multiply by, even if it's like a small negative number, that number still becomes what? Negative. So it's just these analyses which are important. But now let's look at something bigger, something more interesting. So now if we've got something with a denominator, so let's look at the basic, right? So we take this to positive infinity and it's 1 over x. So how then do we go about it? So you want to start asking yourself to say what will be the value of this function if x is 10. So if x is 10, we are thinking it's going to be 0.1. If x is 100, it's going to be 0.01. If x is 1000, it's going to be 0.00. So what's the point here? So you see that this function is going closer and closer to what? To 0. So that's the limit. So of course that's just the basic thing, just for you to be able to think in those directions. Now how do we apply it now in actual questions? Okay, so limit x as x goes to positive infinity, then you've got 5x plus 2, then there. So okay, so let me write it properly. So then, how you can be able to figure out what the answer really is on these questions in a very quick way is by looking at the denominator and the numerator. You look at, is your function either, like, where is your function really heavy? Is it on the numerator or the denominator? So you see that it's heavier where? On the denominator, isn't it? Because if you plug in, because if you plug in 1000 on the numerator, it's just going to be, let's say you plug in 1000 on the numerator, it's going to be 5000 plus 2, right? Because when you multiply that, x times 5, right? But then down you've got a what? You've got a square, so meaning that 1000 becomes 1 million. So you see what's going to happen is that as the value of x goes to positive infinity, what you're going to get is that the limit is going to be what? 0. So you already know your answer is going to be 0. But then how do you show you're working? So we know this is what our answer is going to be. It's going to be 0. But then we want to show our working. We want to know how have we arrived at what? How have we arrived at 0? So that's where now we're going to do the math. So now what you do at this point is you look at the greatest power is what? Is x squared. So what we are going to do is we are going to say 1 over x squared. Our aim is for us to see how really this function is going to behave when we do that, right? So what we are going to do is, because our aim is to get rid of this and see how the function is going to behave. So what we are going to do is we say this and that multiply 1x over 2, then you've got that, Then you've got 1x over 2. Okay, so what does this give us? The limit as x goes to positive infinity is going to be 5 over x. Why 5 over x? Because it's going to be 5x over x squared, isn't it? So you cancel that x, you're going to have 5x. Huh? I hope we've all gotten that. Therefore, then for these others, what we are having is uh, it's just going to be 2 over x squared. Huh? 2 over x squared. And then here it's going to be, this one becomes 1. Now here's the thing. You Then you're thinking, if I plug now a very large number, I plug in, let's say, 10 billion. So 5 over 10 billion, that's it's going to be 0.000. So you just put a 0. And for this one, it's even worse because it's now that large number, even squared with it. Huh? So it's going to be 0 as well. Then you say, on the 7 over x again, it's going to be 0. Then the negative 1 remains. Now we know that 0 over 1, it works. It's 0. Isn't it? It's 0. So again, you see, which was the same thing that we were able to predict from the start. So yeah, you can be able to predict, but again, your working is very, very important, isn't it? So that's something to take note of. So like you would see, let's try out something else where we'll predict again and then see how we can arrive at that answer. So we are going to have limit when x goes to positive infinity, x power 2 minus 5x over 4x squared plus 7. So again, the same thing. If you want, you can do it quick and say the numerator and the denominator, which one has got a higher power. So you see that both have got equal powers, right? Mm, so if they've got equal powers, what you do is you can even say, okay, so I'll do that and do that and do that. Okay, so I'm expecting to get a 2. So you are thinking, so, okay, so I should get something. So what does this mean? It means that if you plug in a number, because the ratio of these two things having large indices, the fact that the ratio between them is 2, it simply means if you plug in, let's say, 8 million, right? Okay, let's say you plug in 1000, it's going to become, when you square it, it's going to become 8 million, isn't it? 8 million, of course, minus something something, like a small number. But yeah, but really, then here it's going to be what? 4 million plus 7. So you see, the point is that the number that you will get at any point will be close to what? Will be close to 2. So that's the reasoning behind what we are doing, right? So that's the reasoning behind what we are doing. Okay, so with this being a plus 7 there. So then having done that, yeah, so at least now we've gotten an depth. Oh, okay. So my answer has to be 2. Now, how do I show the working? So to show the working again, you say the same way we did it in the earlier example. So please, in case you don't get you don't get something, let me know. In case you don't understand something, let me know so that I can answer. I can address it. Yeah? Okay, so what we do here, so we get the same thing, 1 over. I'm not saying that you always have to use 1 over x squared. If, for instance, this was x power 3 and 4x power 3, then we'd use 1 over x power 3. Okay, and that's what I should point. I should bring that one up. There, for this one again, we do that. Okay, so now what we're going to do, the same thing we did. Always remember to write the limit. So here you cancel that, you're going to have what? 4. Then here you're going to have 5 over x. Then here you're going to have 4. Then you're going to have 7 over x squared. So again, now plug in very large numbers. What's going to happen? The 4 remains a 4. Okay, sorry. Supposed to be 8. 8. So you plug in there's nothing you can plug in, it's just 8. Then if you plug x 5 over x, then you put, let's say, 10 billion, because this is infinity we're talking about. So you can plug in any large number you can think of. So you plug in that large number, you're going to have 0. Then 4 remains. Then this one is even worse because you're getting that large number and even squaring it. So you're going to get a 0. So what are you getting? 8 over 4. 8 over 4 is 2, which was the 2 that we found, right? So that's really your way. That should be your approach when it comes to these questions. And once you do that, you won't have problems with these questions. So let's look at another question. Another question. Just in these minutes which are remaining. And also something to take note of is whether the limit is negative infinity or positive infinity, because we know that it can have implications like we saw on our earlier examples. Okay, okay, so that's that, right? So that's x power 3. So then what do you do? Like I said in the earlier example, you look at the two heavy things, the ones which are raised to the highest index. What do you do? 1 over that. Okay, so you do that, then okay, so there we have it. So what do you do? Okay, so there is that, then there is that. Okay, so now what do we do? Then we now plug in our large number. So that 5 over that, it's bottom heavy. So, and of course, we see that we are plugging in a negative infinity, but it's being squared. But yeah, anyway, still 0. Then minus 7, right? Then there it's bottom heavy, so it's 0. Then that's what? 14. Then that's bottom heavy. So what you're getting is negative 7 over 14, which is what? Negative half. Or we could have actually predicted it from here. We say which ones are the large things here? Which ones are raised to the highest powers? You see it's 7, negative 7 and 14. So you just get them and say negative 7x cubed over 14 cubed. You cancel that, you cancel that. So yeah, so you see, so that's how you can be able to find your answers like that. So basically, that's yeah. So that's pretty much how you can be able to answer these particular questions. Yeah, so that's how you can be able to answer these particular questions. So again, like we always say, practice. Huh? So practice the techniques, and once you do that, it will be relatively easy for you to be able to go around them. So yeah, so that's basically that. Mhm. So we continue tomorrow. Just wind up on this and then start continuity.